A few housekeeping notes before we get started with today's presentation. This webinar will be recorded and the recording will be sent out later on today. Also, we will have a live Q&A session at the end of the webinar. Please type any questions you have into the questions bar in the toolbar on the side of your screen. Now, here's Nishi Das, Director of Product Management at Atlantis Computing.
Thank you, Terry. Good morning, everyone. Hopefully you can see the screen. My name is Nishi Das. I'm actually responsible for the ILIO USX product and its launch. I will be talking to you today about the overall product positioning, the use cases, and the target market that we are going after, all the details that may be interesting to you to consider ILIO USX as a solution for your data center. You can see my screen. The agenda will cover two topics. One is we'll talk about the overall trend of software-defined data center and the positioning of Atlantis ILIO USX as a software-defined storage, and why we think that this product can actually solve your architectural challenges with regard to building any large software-defined storage architecture. I'll talk about some key customer pain points that are drivers for us when we were trying to build this product from ground up. We have used these key customer pain points as important indicators for justifying the product design. There's also follow-up slides on the overall product use cases and the basic building blocks of the product. And I'll talk about a bunch of customer scenarios that are relevant to the ILIO USX positioning. Of course, pricing, and then I'll try and open up the floor for any Q&A that you may have. With that, I just wanted to touch upon market trends. So if you look at the slide, you will see two graphs. One is a graph on the left-hand side, which gives an indication of the growth of physical servers in the yellow line and virtual machine in the green line. And this is an annual growth rate that's depicted in the graph. What it essentially shows is there is a huge trend of virtualization that is currently driven in today's data centers. We did some IDC report reading, and one report said that the trend of virtualization, which was around 25% or lesser than that in 2008, has gone to as high as 66% in 2013. And this has increased the density of physical servers from a mere 4 to 1 to as high as 10 VMs per physical machine in today's data centers. Now, what that really does is depicted on the right-hand side graph. It's actually creating a growth in data at a CAGR of around 40%. And this implies that this is a tremendous revenue potential at as high as 11% CAGR for a bunch of vendors in the storage market. But essentially, when we look at this tremendous growth in data, what it means for our customers, a 40% CAGR implies doubling the storage infrastructure every 2 years. And that, to us, is a key pain point that we are trying to solve. Now, there's a lot of buzz in the market about software-defined storage, software-defined data centers. We've had a bunch of vendors like VMware make acquisitions, not just in the software-defined networking space, but in general, everybody in the market is trying to position a story around software-defined data center. So the question that we wanted to ask ourselves is really, what are the key principles of software-defined storage? And what does it mean to the customer today? Is it really relevant from an architectural standpoint? So software-defined data center in general has the concept of abstracting compute, network, and storage, the real hardware from the control plane, and automating everything at the hypervisor layer, which is depicted on the right-hand side diagram, as you can see. In terms of aspects, what really makes a software-defined storage platform, based on all our discussions with a lot of analysts in the market, there are 5 key principles that we landed on. So the first principle is abstracting the storage data plane, which is the real storage, and delivering all data services such as deduplication, I/O processing, pin provisioning, backup, RTO, RPO policies, all from the hypervisor layer. Managing to unify the control plane, unify the entire management of applications on the basis of a policy which takes care of the performance, availability, and reliability of the application is the second principle. The third idea is abstraction also requires pooling all types of storage infrastructure across the data center so that these resources can meet the application QoS. And the fourth and fifth principles are primarily linked to on-demand provisioning, data mobility across clouds, and also optimizing the infrastructure to manage performance and capacity on demand as and when required by the application. So these are the key principles of software-defined storage, which is an essential market trend, and these principles were used by our team in order to design the ILIO USX product. We actually looked at why ILIO USX is the right software-defined storage platform. I wanted to show a small transition of architectures. So if you look at the diagram that I'm showing right now, there was a phase in the market, there still is a phase in some silos in the data center where infrastructure is very, very dedicated, and you have a 1:1 relationship between the application, the server, and the storage. And then came the whole virtualization trend, which initially was started by IBM and really made streamlined by VMware, where server resources, whether it be CPU, memory, or hard disk drives, were utilized to the maximum potential by virtualizing the overall environment. And this meant you could actually pack more VMs onto the server infrastructure. What we are trying to do is we're trying to take this to an extended level where on top of the hypervisor layer, we're adding a software layer which is the ILIO USX data service layer. What it does is it allows us to provide all of these virtual applications with a pooled storage resource, and we supply the pooled storage resource based performance and capacity to the upper layer application based on the demand that the application has. So what we are trying to do is not simply storage virtualization, but essentially creating a layer, a control plane from where all the underlying storage assets can be managed seamlessly, irrespective of their location and irrespective of what storage class they are, to deliver performance, availability, and reliability to the upper layer application. Hopefully this made sense to you guys. I'll talk more about customer pain points, right? When we think about market trends, it's all good, but what we wanted to really do is understand what are the high-level customer pain points in the data center because of this huge growth in data and of the need to have this architectural trend. Why really is it important? So there were 4 large key areas that we came up with. One is for server workloads, whether you take Hadoop or I would say Exchange, SharePoint, Oracle, SQL, databases. There's a lot of over-provisioning or hard partitioning that's done primarily because you want to guarantee a certain amount of performance to these applications and ensure that SLAs don't slip. And that creates large silos of underutilized capacity. When we do sizing from a storage standpoint on a bunch of these applications, we actually have to ensure that the infrastructure has the ability to handle peak performance. So what it relates to is server applications which have a high level of burstiness. These are random I/O applications. They require specialized, dedicated storage environments that are specifically designed to handle the user base or the performance characteristics of that application. That to us is money being left in the data center, money not being utilized, and causing a lot of problems for customers. There are two other important areas. One is the lack of unified management. Not that ILIO USX's positioning is to enable any sort of management platform, but what we are trying to do is we have noticed that in the data center there are multiple types of storage vendors, storage platforms available, and there's no way to actually seamlessly look at the utilization and performance of all these storage platforms in a uniform manner. So what we are trying to do is, with the help of USX, we are trying to enable customers to have better visibility into their environment, better visibility into the storage utilization in their environment. The fourth problem that we think is important to be solved is high availability and TR. Essentially, most customers, in order to meet their high availability requirements, have to double the amount of storage, and the DR infrastructure also increases the complexity of storage systems in data centers today. Now, these customer pain points can be solved by ILIO USX. Let me go into showing you how. Consider the first pain point. What I said was storage is unutilized or underutilized in the data centers. So let's consider two storage silos where VMs are available, are running on the existing infrastructure silos. We add an additional set of VMs to that infrastructure. And what happens is, on the left-hand side, the capacity that's available through the flash is unable to support the addition of these new VMs. If you notice the right-hand side, there is enough capacity on the shared storage, and it can derive the IOPS that's required for these additional apps, plus perhaps for the apps that have been added onto the left-hand side infrastructure. However, these infrastructures cannot talk to each other. Therefore, what happens is the left-hand side infrastructure will require an addition of new storage, which means that each time you add new VMs, you have to linearly scale out your storage. A bunch of vendors in the market are coming out with scale-out architectures in order to enable this trend where scale-out platforms are utilized without disrupting the upper layer application. Now, that's all great, and if you have unified storage all across your data center, it's perfect. You could use a scale-out architecture, no problem. But with ILIO USX, what you could do is just deploy the software on your normal hypervisor. One advantage that you get is you can pool whichever host you deploy your ILIO USX on, you can take all the storage connected to those hosts, pool it together, and there's also the ILIO's core engine data services that's available at the software layer. Essentially, you could do data services like deduplication, I/O processing, compression, all at the hypervisor layer. And what it results in is you can actually add more VMs onto your existing storage infrastructure. For the benefit of USX in this particular pain point is you can max the utilization of your storage infrastructure, and you can add more VMs onto the same infrastructure without changing anything with regard to the application. I'll go to the pain point number 2. Another example where a performance is restricted by the storage silo in which the application belongs. I have 3 application environments. One is for SQL, one is for a database tier, Exchange application tier, and Hadoop, which is running separately. Now, in case my Exchange VMs heat up and there's a I/O contention between them because there are a bunch of users hitting the system, or there's more need to process I/Os at that particular point, what ends up happening is I have a situation where my storage is not able to support my Exchange environment, but I have enough storage lying elsewhere in the data center that's serving the database tier and the Hadoop tier. Again, I'm unable to mix and match any of these storage environments together. What I do is with USX, I enable the pooling concept, which obviously helps me improve the total capacity that's available in the data center and expose it to the upper layer application. What I could also do is I could unique in-memory performance tier and create a pool out of it, which means that there's RAM that's lying free in multiple servers that are supporting these VMs, and I can bring them together to create a performance tier. And what that does is it actually enhances the IOPS that's available to my application without adding any extra infrastructure in the environment. And therefore, I am able to centralize storage, meet my application SLA, and I can do this across silos and across the infrastructure. That's the second pain point. Now, if you look at point number 3, this is a typical design that you have when high performance storage is used to support high availability of applications. What I'm trying to show here is you actually have to have double the amount of storage in order to provide 0 RTO or RPO for the upper layer application. So you have a lot of underperforming storage that's lying elsewhere in the data center, is just sitting there, and you're not doing anything with it. One of the features that ILIO USX has is it comes with an inbuilt HA. Now what that does is HA is built in every segment of the product architecture. So it allows, we're not saying remove the whole HA infrastructure that you have. What we are saying is you could reduce the amount of storage that you're currently using in HA. What you could also do is some of your underperforming storage and add it to your storage infrastructure. And with the HA that's already available, you can enable HA with minimal amount of storage rather than having double the amount of storage and adding multiple licenses to it. Therefore, critical application performance becomes manageable and you could use your capacity for more important requirements in the data center rather than let it stay wasted for scenarios where disaster will actually come into play. So that's the third use case. I'll talk about the fourth pain point, which is a lack of unified management across different types of storage. Now, as I suggested before, we do not want to be a management platform. What we want to do is there are different types of management platforms already available, and these are our partners whom we want to work with, but we will also want to enhance the features that they bring on the table to the data center customers. And essentially, we also want to add the feature of RAM and HDD visibility across multiple resources in the data center. ILIO USX, what you could do is there are REST-based APIs. All these REST-based APIs can access our basic feature of making free storage available to multiple application layers. And there's VAI compatibility also built from which fast cloning can be done. And having the APIs allows us to actually utilize storage, including RAM and hard disk drive and flash, across the data center by different applications, and then move those metrics onto any type of dashboard that you may have. It may be Symmetrics, it may be on command from NetApp or Tivoli or Remedy, or you may have open source, anything that's available. Our APIs allow you to integrate with the front-end management platform of our partners and actually improve the visibility that you have on your capacity utilization and performance across the data center. So these are the 4 pain points that we are trying to solve with ILIO USX. Therefore, in order to, ILIO USX actually has a bunch of benefits that we try to bring on the table for our customers. One is you can do more with the storage you already have. We believe that a lot of storage is underutilized, not managed properly. Our value proposition is we can take that existing storage and improve the performance that you have on that storage. Unique in-memory performance, like I explained, there's a lot of server RAM which is very fast and is not being utilized in the data center as a performance pool. We can definitely make that happen for our customers. We can turn DAS into enterprise-grade storage. What this does is it further brings the cost down for our customers because DAS will actually now be used in conjunction with SAN, NAS, or Flash, and it can be turned into an enterprise-grade, reliable data source. There's a lot of flexibility built into the architecture, which means you can abstract and pool any type of storage, whether it's SAN, NAS, DAS, SSD, or Flash, or even local server RAM. From a management standpoint, everything is policy-based, so you could actually define capacity, performance, and availability policies for your application based on the free storage that's available in the data center. And the provisioning is instantly done with the help of our UI. Therefore, things really work seamlessly. And what it ends up doing is it actually helps our customers lower their storage costs, but by as high as 50%. And it also increases the storage utilization so much so that you do not have to waste capacity to derive the application performance that you need for your upper layer application. I'll jump quickly into the product use cases and the components of the product. Before I go into the use cases, I definitely want to talk about some of the building blocks. You can see the building block of USX design are something called aggregator VMs that consumes all types of discrete storage lying on all the hosts across the data center. These discrete types of storage can be disk, flash, or memory. What we do is we generate something called pools out of these aggregators, and these pools can be of 2 types, memory or capacity. And they are consumed by the upper layer application-defined storage volumes, which are of 4 types, hybrid, in-memory, persistent in-memory, and all-flash. And these application-defined storage volumes are then exposed to the application VM. And the basic benefit of these application-defined storage volumes is it can consume pools that are created from resources lying anywhere in the data center. And that's the real flexibility that we provide in our architecture. The thing about USX is it comes with an inbuilt HA architecture. So what this means is at the pool level, we actually provide enterprise level HA, which is in an MS-to-N model. What that means is we don't have a 1:1 model, and we are not wasting resources to provide HA at the pool level and the ADS volume level. What we instead do is we have an MS-to-N model that implements the level of redundancy required but does not waste any additional capacity for our customers. We have tested for data consistency and integrity, and we find that in these environments we do not have a huge problem. We do not have any problem with regard to keeping the data consistent, which is of primary concern to our customers. Failover also happens seamlessly within seconds, and we enable this across the architecture. So this is a very important design concept of ILIO USX. And with that, I will jump into so-called software-defined storage models that are available with ILIO USX. And these are the models that are important when we try to define capacity, availability, and reliability scenarios to the upper layer applications. So as you'll see in the right-hand side diagram, I'm showing different types of resources. So you have local flash, you have RAM, which actually talks to a memory performance pool. And then you have flash shared, NAS or SAN, or direct attached storage that can talk to capacity pools. And a combination of the capacity pool and the memory pool creates what is called an application-defined volume. And this application-defined volume, based on the size, the HA features, and the combination of pools, will have different performance characteristics, different availability characteristics, different capacity characteristics. And they are exposed to the upper layer application VMs, thus enabling the VMs to have the flexibility in terms of performance and capacity that's required by the VMs at that time. With this particular model in mind, we define 4 types of application-defined storage. So what are the 4 types? The first type is called hybrid storage. What this means is it's an in-memory storage model, in-memory pool, that is combined with a storage capacity pool that can be created using NAS, SAN, flash shared, or DAS. And the combination is exposed to the application-defined volume. That is a simple hybrid model, which is actually depicted by the right-hand side diagram. If we go into the second model, it is the in-memory model. And what that means is you do not use the storage capacity pool anymore. However, you only work with the performance pool, the memory performance pool, which can be made of RAM or flash. And what you do is you RAID between the hosts, between the multiple hosts from which the RAM is pooled, to provide a level of redundancy in the architecture. In the persistent in-memory model, again, the memory pool is the primary storage tier from which the application-defined volumes are created. However, there's also a small redundancy that's built at the back end to persist some of the data from the memory pool, and therefore we create an ADS volume type called the persistent in-memory model. There's a 4th model that comes into picture, and it's called the all-flash module. And in the all-flash module, we actually just create a storage capacity pool using a flash array and expose it to the ADS volume. So if I were to define what I just verbally explained to you in detail, you'll see in my slides there are 2 diagrams. One is a functional diagram of the hybrid volume layout, and the other is a physical diagram representing the same hybrid volume layout. So if you'll see the left-hand side diagram, it's a combination of the memory pool and the capacity pool that goes to the application-defined volume. And in this architecture, the role of the memory pool is primarily to speed up the operation, the I/O operation, or any of the application performance operation on the overall infrastructure. So what we are doing is, on the right-hand side, you can see it's a very simple pooling of server RAM that is available across the 4 servers. And we create a capacity pool from the local DAS that's available on the 4 servers, as well as the shared storage connected to all the 4 servers. And then we expose the combination of this capacity pool and the memory pool to the upper layer application VM through what is called the application-defined volume. So this is a very simple model, and it is the most accepted or used model in most of our beta deployments. And we think that this model is very stable in enabling our customers to achieve the level of flexibility they want in their environment and also get the performance benefits for the applications that they are trying to support. Now, the second model is the in-memory volume layout. So if you look at the left-hand side diagram, there's no storage capacity pool there. It's only the memory performance pool. And the memory performance pool is is talking to the application-defined volume, which supports applications such as Hadoop. And primarily, if you see the right-hand side diagram, we have created a shared in-memory pool out of the RAM available on 4 hosts. And this layout is actually very interesting for analytical applications, primarily like Hadoop or NoSQL or Cassandra or any type of analytical applications where you have to support multiple nodes with a lot of data and do parallel processing. What is really key here is it speeds up the operation of the overall environment because of the performance here, and there's a redundancy built between the hosts. But it's not a very, very redundant architecture. It is an architecture that's very suited, well suited for an environment where a customer is considering just adding flash onto the servers, or a customer wants to quickly improve the performance of their existing server infrastructure. Now, in order to remove some of the issues that customers may have or concerns that customers may have with using a pure in-memory model, we also propose a persistent in-memory model. What this does is the primary tier here, where the application-defined volume connect with the underlying resources, is the memory pool. So the memory pool is created by the RAM or the flash resources across the 4 servers. And the shared in-memory pool is then persisted by replicating to the backend so that there is some copy of the data apart from the redundancy that is already built between the hosts. And this adds an extra layer of redundancy on the data in case a customer is concerned about retaining the data and not losing it. So this is the other model that's available for our customers and can be created using the ADS volume. The fourth model is all-flash. And what simply this is all-flash allows a customer to create a storage capacity pool, which can consume all the flash arrays across different hosts, across the 4 hosts that I'm showing in this diagram. And that optimized flash pool can then be exposed to the application VMs. In this example, I'm using SQL, and the ADS volume is exported to the SQL VMs using your standard NFS, iSCSI, SIP, and so on and so forth. So as a summary, the ADS volume is, there are 4 formats of the ADS volume that's available to our customers. One is hybrid, the second is in-memory pure, the third is persistent in-memory, and the fourth is all-flash. And a combination of these volumes or different types of volumes can be used to generate the required performance, capacity, and availability characteristics that customers need from their existing storage or new storage that they may want to buy in their environment. But our basic goal in the overall architecture is to make sure that storage utilization, whatever you may buy, improves and that you can derive maximum benefit out of your infrastructure. If you look at customer scenarios based on what I discussed, there are certain trends that we are looking for. Amongst them are scenarios where there is uneven performance between different types of storage that's not interoperable, coming from different vendors, different classes of storage that do not provide an equal amount of performance. There's a lot of virtualization growth that is pushing the infrastructure to have a linear scale out. Those are scenarios where we can be useful. We are also useful in an environment where storage consolidation is a key driver, and there's a budget shift going from infrastructure to applications because applications are more important to the core business of data centers and our customers. We also want to position ourselves into environments where the HA and DR requirements are growing, and they have really added a lot of cost pressures and management pressures on our customers. We would like to help in that environment. And then there is also a key aspect of data migration between different data centers, private to private and private to public, where we have key features that we think can really utilize the overall environment and benefit our customers through ILIO USX. So one aspect is capacity optimization and what we could do around that. Other aspect is application performance optimization. So when it comes to performance, one is we want to talk about how we could improve storage performance, which is improve the IOPS or improve the storage utilization for critical applications in the environment. The other is we talk about application performance and what we could do to derive more from existing storage. And in that scenario, we have a bunch of ideas or rather use cases for different applications. One is Microsoft Exchange. So if you see Exchange environments, the easy use of USX is you could support more mailbox from the same infrastructure. You could increase the quota size per user because we do a lot of data services on your existing storage infrastructure. And you could also improve the average message size and the I/O hitting the system because of the, again, because of the data services that we provide at the USX level. For SharePoint also, it means the same thing. You're increasing the number of supported users, you improve the average web size or the request per second, and perhaps more metrics that we can actually help with. From a database standpoint, we've done some work on SQL, and we're working on Oracle, but we definitely see that we are able to improve TPCP rate benchmarks for multiple database environments and also reduce the I/O contention that may happen from the app tier. For Hadoop, what we think we could do is improve the average size of data being processed and the average time that Hadoop takes in order to process data in their overall environment. We also believe that there are a lot of large batch processes that happen in customer environments that typically take 14 to 16 hours. And with our product, we can help customers reduce the batch processing times on these in these environments by making the performance across multiple storage arrays seamless and uniform. So these are some of the target scenarios that we have from an application performance standpoint. So in short, there's 3 areas of differentiation for ILIO USX. One is we provide data services, data optimization services at the hypervisor layer, and these include deduplication, compression, I/O processing, cloning, and thin provisioning. We can aggregate all types of storage, so irrespective of whether it's SAN or NAS, SSD, HDD, local server RAM, or flash array, we can talk to anything and unify our APIs across them. Our target workloads are primarily Hadoop, Exchange, SQL database, Oracle database, SharePoint, and environments like that where virtualization is a key trend and storage bottlenecks cause performance issues. So our value prop, just to repeat it again, is ILIO USX is a pure software solution and it covers the entire range of storage classes. There is a unique in-memory technology which comes from the traditional VDI platform, and all the optimization data services are already built into this product. These include deduplication, compression, I/O processing. ILIO USX also comes with inbuilt HA, and it covers a large gamut of server applications where customers can derive a lot of benefit by using us. And the architecture is extremely flexible because it expands into memory and capacity pool, and there's literally no hardware restriction in terms of scale. In terms of pricing, I do want to touch upon this quickly. Our pricing will be based on dollar per terabyte. And when we talk about the terabyte or the capacity based on which customers will pay, we think that there is a back-end storage which customers would have to order if they did not have ILIO USX. And our value proposition is that customers can do more with the capacity they have at the back end. And what we do is we do our storage optimization services on the back-end storage, and then we expose front-end storage to the application tier. And our idea is actually to charge customers based on this front-end application, based on the value that we derive, that we can derive from the back-end storage. And therefore, the costing is based on dollar per terabyte and primarily pegged on the front-end application-based storage that is exposed to the upper layer VM. In summary, what I want to leave you with is ILIO USX's positioning is primarily to help data center customers manage a rapid growth in virtualization, pushing data costs and data management overhead, and actually making the management of data in data centers extremely difficult. We are primarily trying to help customers with any limitation that they may have in managing their overall storage to deliver the performance and capacity required by their application tier. The USX primarily tries to flex storage infrastructure in order to meet 5 primary goals. One is we extract storage. So we are creating a management platform that abstracts DAS, SAN, NAS, flash, any type of storage, any class of storage lying anywhere in the data center, so that it gives the customer the flexibility to manage their infrastructure based on the application requirements. We optimize the existing infrastructure, which means we allow customers to optimize their capacity utilization. We also allow customers to use their capacity to derive maximum performance out of it, so that applications are never left dry and underperforming, and there are no slippage in SLAs. We also automate the overall deployment process. There's instant provisioning, there are push buttons. The product is actually hypervisor agnostic. It's also storage class agnostic, which implies you can actually push a button and see what is going on in the environment, just deploy the product, see the free infrastructure, and start using it to benefit your upper layer application. We also utilize your storage to the maximum ability in order to deliver the performance that you need. And our REST APIs and the VAI plugins that we have will allow you to orchestrate across data centers and different types of storage, and also have visibility into your environment. So hopefully these are benefits that will actually get you thinking into the flexibility that USX provides and the benefits that we bring on the table for our data center customers. I do want to leave you with some resources that we did the first launch for the product on February 11th. There was a huge reception in the market. We've also worked with VMware Virtual SAN, which is another product trying to do the same thing. It actually combines DAS with an SSD tier and creates the whole concept of pooling. We have done work with them, and we've actually worked out a performance number that improved vSAN performance by 4 times. So the white papers and blogs are available on our website. There's also a solution brief that's available. There are business and technical FAQs, and also an IDC report that explains why ILIO USX is the right software-defined storage platform if customers were to consider the same in their environment. We will be publishing a bunch of other documents that will be available on the website, and we are going through a lot of POCs right now, and we're also trying to help our partners get certified so we can build momentum into the market. So if you have any questions or on this presentation, or you want to get involved in the partner certification programs, or are interested in doing a POC, please send me an email. My contact information is visible on the slide deck, and I'll be more than happy to engage with you through our sales team and help you through your evaluation on ILIO USX. Thank you so much, and I think I'll open up the floor for any questions that you may have.
Thank you, Nishi. Our first question today is, in the reference architecture with vSAN, you are supporting 375 VDI desktops with USX. How is that load licensed, by terabyte or ILIO licensing?
So it is still, that's a very good question. The scope of the ILIO USX product is not covering VDI right now. So if a customer would like to use ILIO USX, we would actually advise them not to put VDI there. When you consider ILIO USX pricing for every other server workload, it will definitely be $1 per terabyte. With vSAN, we definitely went ahead and did VDI, but that is not a use case that we want to launch into production environments or test and dev environments right now. So there's no merging of the VDI licensing with the USX $1 per terabyte licensing currently.
Thank you, Nishi. Our next question is, I am doing a pilot with Windows 8.1 for a VDI implementation. I think this would be a great fit for me, but I need to know if Windows 8.1 is currently supported.
Yeah, like I mentioned, maybe I didn't mention this a lot in my presentation. VDI, ILIO VDI is out of scope right now for ILIO USX platform. What we want to do is in the next 6 to 8 months, we want to unify the platform so that you could use your VDI infrastructure on USX, but right now we are not doing that. Therefore, if you really want to use Windows 8 and you want to do a VDI deployment, we would recommend not considering USX.
Great. Our next question is, with USX, are you trying to do a similar thing like EMC by PR?
Yes and no. So EMC Viper is definitely considered to be software-defined data center, software-defined storage play in the market. It's a strategic move made by EMC, and I have great respect for EMC. But there are definite differences because what EMC is trying to do, and there's not a lot of literature available on this, but in my personal opinion, which again is personal, EMC is trying to create a common management platform, of course, but the APIs try and connect with every storage platform, and they are pitching that you could, or what I understand from the limited information that I have is you can create LUNs and you can integrate the APIs and do all the data services directly from the management plane, but the APIs are going to the underlying platform, and there's really no concept of pooling that they do or optimization that they do across the architecture. So I don't know if we can compare EMC's architecture to ours, apples to apples. Our value proposition is completely different. I think EMC's vital positioning is probably catering to the need of unifying the OSs of their multiple storage platforms, as well as doing something that NetApp does with vSeries. But it's not really direct competition, or rather I would say the architecture is very different from ours.
Thank you, Nishi. Our next question is, what happens when a RAM chip goes bad? Do I lose the data that was stored on that chip?
Yeah, so if you don't lose all the data that was on the chip. If you have a pure in-memory model, we are building some protection between the hosts. So there is a layer of redundancy built in there, but yeah, there are challenges. Some data may get lost because it's not been written or it's not there in the buffer. Therefore, the persistent in-memory model becomes more valuable. But we will have to look at the overall environment and the speed of operation and read-write ratios in order to advise you exactly.
Great. Our next question is failover a restart of VMs, or is it active running without interruption?
It's active running without interruption.
Great. And our last question today is, does ILIO USX provide a superset or a subset of features over ILIO for VDI?
It's a superset because ILIO VDI has a session host and a replication host. It's a 1:1 relationship. It optimizes the storage available on one host. It does not do pooling across multiple hosts, and it does not unify management. It doesn't have inbuilt HA. But it has all the data optimization, which includes deduplication, I/O processing, compression, etc. So what we are doing is, we took the base ILIO VDI product and the data optimization that it already does and extended its features to include pooling, flexing the architecture, unify management, create application-based volume layouts that actually improve the performance and made it server workload specific. So long answer short, yes, it's a superset of the features that are already available in ILIO VDI.
Great. We actually had a few more questions come in. So our next one is there a model where you are exposing logistical units of storage or file systems that span physical storage boundaries, or is it only tiering?
We do not use the file system of the physical storage. We are using our file system. So yeah, the LUNs already exist. I mean, the LUNs, the data stores are already visible to vCenter and all the and ESXi. All we do is we carve out chunks of free storage from those data stores or LUNs, and then we pull it together and use our file system on top of it.
Great. Is per terabyte licensing based on physical storage managed by USX?
No, per terabyte licensing is based on the physical storage that customers would have had to buy if they did not have USX. So it's really based on the virtual storage that we expose to the upper layer application.
If I wanted to host my regular server VM, which model would I use?
I would recommend hybrid. just because we've seen a lot of performance, good performance with hybrid volume layout, and it doesn't have any major redundancy issues, as in it doesn't have any sort of concerns or what happens if something goes down and blah. There's no loss whatsoever. I don't mean to say that there is any loss in the other architectures, but I think for the best model, if I were to ask a customer, all flash or hybrid is the best model. And in-memory should be used where performance is really the primary key and you really don't care about preserving the data all the time.
Okay, and our last question. Can ILIO for VDI be run on one set of servers simultaneously with USX running on another set of servers?
Very good question. Not yet. You can run it, but if you want to unify management across them, and there'll be some amount of customization that needs to be done. The benefit of USX cannot be derived and extended to the VDI environment yet. We will make that available in the next 6 to 8 months.
Okay, well that was all of our questions for today. Thank you again, Nishi, for this presentation. Again, this webinar will be sent out this afternoon. We will be hosting a technical deep dive session this Friday, the 21st at 9 a.m. Pacific time. If you're interested in attending, please go to atlantiscomputing.com/events or reply to the follow-up email and I can send you the link to register. Thank you again for attending.